All right, guys, we're into chapter 8, section 8, difference of squares. So previously we factored trinomials into two binomials. Now we're going to factor binomials that are the difference of squares and use difference of squares to solve equations. All right, so that's our vocab, difference of two squares, so let's talk about it. You've previously learned about the product of the sum and difference of two quantities. The resulting product is referred to as the difference of squares. So the factored form of the difference of squares is called the product of the sum and difference of two quantities. So a squared minus b squared factors into a plus b times a minus b, or you could write it as a minus b times a plus b. Here's why. Because when you had a minus b times, you could do this the other way, a plus b, a minus b. When you FOIL it, you get a squared plus ab minus ab minus b squared. And the ab's cancel out the outer and inner terms, leaving you with the first term squared minus the last term squared. Okay? So, if we want to reverse that, notice you have the difference, which means subtraction of two squares. Something squared minus something else squared. So if you have something of that form, you can automatically factor it into a minus b times a plus b, or a plus b times a minus b, as you see in these examples up here. Now, you don't have to put both ways, okay, unless they specifically ask you to. If for the first one, x squared minus 25, you could think of that as x squared minus 5 squared, and so it factors into x plus 5 times x minus 5. Or, like it says, you could write x minus 5 times x plus 5. Okie doke. All right, so let's factor this one. Now, in the examples under the key concept, they gave you a couple easy ones. Now, these ones are kind of easy once you learn the flow for them. So when you see something like this, you always want to first see if you can factor out a GCF. Well, there's no h's in this term, and there's no a's in that term. There's nothing that divides into 16 and 9 at the same time, so there's no GCF, okay? But since it's a subtraction and I have some squareds there, I want to think of it as something squared minus something squared. Well, what would this have to be if it was something squared? It would have to be 4h quantity squared, and this would have to be 3a quantity squared. So now I have it written in the form something squared minus something squared, and those somethings are what you use for the a and b in the pattern. So you can go right to the factored form as of 4h plus 3a times 4h minus 3a. All right. And again, you could have written it as 4h minus 3a times 4h plus 3a. You only need to write it one way. Just make sure one's plus and one's minus. Okay. In part B, again, look for the GCF. If there's no GCF and there isn't one, see if it can be a difference of squares. 121 is what squared? Okay, and 4b squared is what squared? Right, it's 11 squared minus the quantity 2b squared. So the 11 is going to play the role of a in the factored form, and the 2b is going to play the role of b. So it factors into 11 minus 2b times the quantity 11 plus 2b. Okay, see, this time we wrote it with the minus first and then the plus. Again, if you wrote it as 11 plus 2b times 11 minus 2b, that'd be fine. Just don't write it as 11 minus b times 11 minus b, or 11 plus b, 11 plus 2b times 11 plus 2b. No, one has to be plus, one has to be minus. All right, now look at this one. There's no squareds, but if you look at 27g cubed and the 3g, you can factor out a 3g from both of those. So factor out a 3g, and then you're left with 9g squared minus 1. Now, a lot of people get stuck whenever there's a 1 here, and they think, oh, that can't be difference of squareds. But remember, 1 squared is itself. So you could write this as 3g quantity, and then the inside the parentheses here is a difference of squares. You could think of 9g squared as the quantity 3g squared minus 1 squared. So 3g is going to play the role of a, and 1 is going to play the role of b. So you would have the 3g minus 1 times the 3g plus 1. But don't forget to multiply by that factor of 3g that you factored out way at the beginning up here. Okie doke. Here's a couple for you to try. Go ahead and pause the video. Okay, we're back. Number 1a, you can write that as 9 squared minus c squared, which would be 9 plus c times 9 minus c. 1b, you could think of that as 8g squared minus h squared, which would be 8g minus h times 8g plus h. Right, 1c, you could factor out an x and write it as 9x squared minus 4. And that's going to be x bracket 3x quantity squared minus 2 quantity squared. And that's going to be x times 3 minus 2 times 3 plus 2. Okay? And 1d, you could factor out a negative y. So you have 4y squared minus 9. Okay? And then you can think of the 4y squared as 2y quantity squared and the 9 as 3 quantity squared. So it would be 2y plus 3 times 2y minus 3. Okie dokie. All right, let's keep going. So to factor a polynomial completely, a technique may need to be applied more than once, and this also applies to difference of squares pattern. So if I look at b to the 4th minus 16, b to the 4th is really b squared squared, and then 16 is really 4 squared. So I could write that as b squared plus 4 times b squared minus 4. But notice the b squared minus 4 is also a difference of squares. Pretty cool, huh? And I could think of b squared minus 4 as b squared minus 2 squared and then factor that one. b plus 2 times b minus 2. Now, I will tell you, if you have the sum of squares, like something squared plus something squared, like this b squared plus 4, that does not factor in the real numbers, okay? In Algebra 2, you might talk about how to do that, or in pre-calculus. That's a little bit more involved and beyond what we know, okay? So you won't have to factor sum of squares unless you can pull out a GCF, but you can't do it like you did the difference of squares. All right, 625 minus x to the 4th, you could write as 25 squared minus x squared squared, which is 25 plus x squared and 25 minus x squared. The 25 minus x squared, you could factor as 5 squared minus x squared, so it becomes 25 plus x squared times 5 minus x times 5 plus x. Let me back up here a second. Just make sure you had time to get that. Okay. All right, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. Number 2a, that factors into y squared plus 1 times y squared minus 1. And then the y squared minus 1 factors, again, as a difference of squares, is y plus 1 times y minus 1. Number 2b, you have 4a to the 4th minus b to the 4th. You could factor as 2a squared plus b squared times 2a squared minus b squared. Now be careful. This 2 is not a perfect square, so I can't continue factoring that one, okay, because that's technically not a difference of squares because 2 is not a perfect square, so you just stop there. 2c, 81 minus x to the 4th. 81 is 9 squared, and x to the 4th is x squared squared, so you could think of that as 9 plus x squared times 9 minus x squared. And the 9 minus x squared factors. So let me rewrite the first one. It's 9 plus x squared. And then 9 minus x squared factors into 3 plus x times 3 minus x. And then the last one, 2d. 16y to the 4th is 4y squared, quantity squared. So it'd be 4y squared plus 1 can be thought of as 1 squared. So that's just 4y squared plus 1 times 4y squared minus 1. And then the 4y squared minus 1 is also a difference of squares. So you have 4y squared plus 1 times 2y plus 1 times 2y minus 1. Sound good? All right. Sometimes more than one factoring technique needs to be applied to ensure a polynomial is factored completely. So let's try these ones. 5x to the 5th minus 45x. All right, so if you look, both terms have a factor of 5 and x, so you can factor that out. So it's 5x times x to the 4th minus 9. Then x to the 4th and 9 are both perfect squares, so I could factor that as x squared minus 3 times x squared plus 3. Again, even though the x squared is a square, 3 is not a perfect square, so we're not going to keep factoring as this is a difference of squares, so we just stop. Same thing we did in example 2b on the previous slide. All right, let's check out this one. If you notice, all of these have a factor of 7 in them. So I factor out 7. Then I get x cubed plus 3x squared minus x minus 3. Now there's no GCF of any of those. It's not a trinomial. There's no like terms to combine. But what's the other method that we learned whenever there's 4 terms? Right, factor by grouping. So I can group the first 2 terms together and the second 2 terms together. If I group the first 2 terms together, I can take out an x squared. In the second group, I can take out a negative 1. Now, they did it early here, which is fine, but they factored out a negative 1. Okay? And then notice both of them have a factor of x plus 3. So I could factor that out, and you'd have 7 times x plus 3 times x squared minus 1. We're still not done, though, because you see x squared minus 1 is a difference of squares. So that completely factors into 7 times x plus 3 times x plus 1 times x minus 1. I know, a lot. But it's pretty cool, huh? All right, 4 problems there for you to try. Go ahead and pause the video. Okay, we're back. 3a. Let's take out a 2 first, and you get y to the 4th minus 25, which is going to be a difference of squares. Y to the 4th is y squared squared, and 25 is 5 squared, so it'd be y squared plus 5 and y squared minus 5. Now, the y squared minus 5 is not a difference of squares because 5 is not a perfect square, so we're done. 3b, 6x to the 4th minus 96. You can factor out a 6, x to the 4th minus 16. Had to think about that one for a second. Now, x to the 4th minus 16 is a difference of squares, so that would factor into x squared plus 4 times x squared minus 4. And then that, x squared minus 4, is another difference of squares. So it's x squared plus 4, or 6 times x squared plus 4 times x plus 2 times x minus 2. Okay, 3c. There's no GCF, but if you group the first 2 terms together, I can factor out an m. So you have m times 2m squared. Or you can factor out an m squared, rather. Let me get that off there. So you would have 2m plus 1. And then the second group, you could factor out a negative 25. You have 2m minus 1. So this would become 2m plus 1 times m squared minus 25. And the m squared minus 25 is also a difference of squares, so keep the 2m plus 1. And you have m plus 5 times m minus 5. Okay? All right, and then 3d, you can group the first 2 together, factor out an r squared. And then you'd have r plus 6. Forgot to put the group. And then we group that one. The second set, and you factor out an 11, so you have r plus 6. And then take out the r plus 6, so you have r plus 6 times r squared plus 11. And notice this r squared plus 11 is a sum 11 is not even squared, so you can't do the difference of squares formula, so that is the answer there. Okie dokie. All right, guys, that's it for this video. Please stay tuned for the second half, and we'll see you there.